Hello explorers, and welcome to another little tutorial where I'm gonna talk about data structures in Java. And we are talking about data structures that we call collections. And if you hear some noise in the background, well, we have snow in Sweden, and at the moment we have these plows going around the neighborhood and taking away some of that snow so we can get on with our lives. So let's talk collections today. We know that we in our system could have these primary types called ints, for instance, natural numbers, and we also have some kind of objects. These are a little bit more involved things, and there is actually something called an integer, and that's an object of this integer. And that's important, and I will tell you why later. So we have this simple data structure where we can talk about numbers, and there's strings and so on that we can talk about, letters and so on. But let's keep to these simplest of things, because we don't want to talk today about the specific types. We want to talk about how can we take these types, bunch them together in some structure that makes sense so we can have a lot of them. And these kind of data structures are collections. So a collection is a bunch of data. Just a bunch of data. So if we have a few integers here, these are a part of a collection. Simple as that. And one of these kind of data structures, which isn't actually a part of the interface collection, is the array. The array is a very simple data type. It's more of these pure data types than the object data types, because an array as a specific entity is not an object in itself. In arrays, we usually depict them by saying brackets, and then we have some type before. So if we say brackets int brackets, that's a bunch of ints, a few of them. And we can have multiple brackets if we have a nested sort of structure down there. And to create some of these, we could actually just give this a new, and again int, and then brackets with a number in it. So we tell the system how many of these ints we got. Yeah, that's pretty simple. So to make this simple, I typed it out here. We have some int bracket that we call n, which is our array, and that's equal a new int bracket of 5. So we have 5 integers in there. And if we want to use any of them, we can use this new value that we have n, and we just use brackets, and then we can say some number between 0 and 5, but not 5. So between 0 up to 5, because we have 5 elements and the first index is 0. So if I say 0, I can either get the value from 0 as a normal variable, or I could just tell this 0 position that's a 1. So that's simple enough. This is the way to use arrays, and these could be used in loops and so on to gather a bunch of data. Whew, it's getting hot in here. So let's continue to talk about collections specifically. So in collection we have a bunch of different types that could talk about these kind of structures in another meaningful way. But the thing we need to remember is that the simple types we had before, ints, and also floats and doubles and so on, those are not welcome in a collection, because a collection is a bunch of objects. So we need to use these objects of the simple types. So the integer, and then we have a double with a big D, and a float with a big F, and so on. And those are the ones that we need to use. And string and so on are also objects. And those we can put into a collection. So we have a few different collections. I would say that the simplest of them is called a set. And the set is something that you put something into, and in that you only have one of them. So it's a unique collection. You can't have more than one instance of a specific value in a set. And those are pretty nifty if we want to make unions and talk about different things between sets and so on. And then we have the list. This little collection is interesting because if in a list, if you put something on a list, you put it on the end of the list. You can walk through the list with an iterator from start to finish, and you always put the value last. So that's one way to use things. And then we have a stack. And this data structure is a bit weird, because in a stack you put things on top of it and you take things off the top. So you put things in on the top, you can read through it as you do with a list, but when you take something out, you pop it out from the top. And that's the difference. In a list you can remove something wherever you like in the list, and a set as well. You can remove some placement in the list. You say, at number 5 I have some object that I want to remove. And then we have this queue. And this is also an interesting data structure, because in a queue you put something onto the queue, and on the other end of the queue you pick it out. So you can say, I want to have these 5 elements, and I put them in 1, 2, 3, 4, 5. And in that order you will also pick them out. 1, 2, 3, 4, 5. So they will come in the same order as you put them in. But you put them in one end and take them out in the other end. And then we have this collection called a vector. And that's pretty much what we had before with the array. You put stuff into the vector, and it works and handles the data exactly like an array. The difference with a vector is that this can expand. So a vector doesn't have a specific size, it can have any size. And in our case we had an array of 5. So when we have filled it with 5 things, it's full. We can't change the number of values we have in there. And we can't either have 3 elements in a list of 5. You always have 5. But if you ask a set at the beginning, when you haven't put anything in, how many elements do you have? I'm empty. I have no elements. I have a length or a size of 0. So that's another thing that distinguishes these kind of work. And see, have I talked about all those? I have one more structure that is interesting, that is not in the collection. There's a bunch of operations you can do on collections as well. You can sort them and work with them like that. But we have one specific collection type that isn't actually a collection. It's something else, but it's very useful and could be interesting to know about that it at least exists. And that's the map. And a map can have a lot of different implementation. You can have a hash map and so on. a hash. Yeah, there's a few of them, but the key element of a map is that in a map you put something into a map, but you assign it a key. So, for instance, if I want to put the value 5 in, I can say that on position 2, I want a 5. If 2 integers are my keys, but I can as well say that I have a key that is a high. The string high is my key, and in my string high I have a value of 42. Or I could have a string map. So I decide what's my key of the map and what's the value of my map. And these two are both objects. And this makes things very interesting, because you can work with a map and say that I want either the keys of the map, I would like the values of the map, and iterate over those. And you can also say I want the entries of a map. And if you say that, you will get an entry and it's actually an entry on the object map. So you would say map.entry, and this will have the definition of your key and your value, and the object out here, if we say that my entry is E, and if I work with an E, if I loop over these or iterate over all the entries in a map, I can use the E value and just say get key. Or I could say E dot get value. So that's a very efficient way to go through the full size of your list, get all the keys and all the values. So if you have a store where you want to store key value pairs, you can use this technique to loop through all your key values and print them out. Just say that I want to print out this key equals this value, and that's a very simple way to print them out, and it's very efficient to work through a map. So those are the data structures I wanted to talk about today. I hope you learned something, and I'll see you in the comment section.